Hey guys, so in this video I'm going to show you how to find the range and the height of a given projectile. Okay, these are the values we're going to use, and if you don't know what these values are, then I highly suggest that you see the last video, otherwise you will be confused. Okay, so usually in questions or in exams they ask for finding the range of a projectile. Okay, and we're going to work with the range first. So by range, what they mean is like when an object is projected and then falls down, and the distance it covers on the x-axis, so basically on the plane, how much distance it covers. Okay, so the distance it covers is x itself. Now you might think, why is it not ux? Well, it's not ux because the length of ux over here, or like the length of ux and the length of u, which I forgot to mention, is not actually a calculated value on the graph. But what I mean is, like, the length of u does not matter. U has a magnitude with a direction, but that magnitude is not the length of this. Okay, the u length can be great, bigger and bigger, but it will still have the same magnitude. The graph over here, let me just bring this down, y and x, what this is actually in meters. This is the height in meters, this is the length in meters. So the xy graph is in meters. These are, like, let's say, gradients that we calculate. Okay, so in a distance time graph. This is not a distance time graph, by the way. This is not time, this is not distance, no. These are both in meters. Okay, this is height in meters, this is length in meters. So as I was saying, in a distance time graph, it would be the gradient. So this is somewhat like gradient, but not exactly. Alright, so x is our distance or range, as you might call it. And the formula we'll be using is s equals vt, or in this case, s equals ut. Why we're using this formula is a very crucial part, because in the x axis, there is absolutely no acceleration. So when there is no acceleration, we use this formula, because in this formula acceleration is zero, your velocity is constant. So we're using u because we're mostly working with initial velocity, right? So now what we do next is put in this into this x equals, so I've substituted s with x, okay, and u I'll substitute with ux. Why is that? Because we are working with in the x plane, so whatever values we will use is the x value. Alright, so we'll use ux times time. That's simple. We use time, we don't use tx, because time doesn't matter. Time is independent variable. It doesn't matter what direction it's going. Time itself doesn't have a direction. It's scalar quantity. So it's absolutely independent, and we leave time as that. Now let's substitute everything so that we can use it correctly. I'll substitute x for s again, because we're working with distance or range. You might put it in r, but it's most probable that you put it in s. In ux, we have the value u dot cos theta times time. We simplify it, s equals ut cos theta. This is a crucial equation that you have to learn. This applies for every projectile motion. Okay, and this projectile is in the x-axis. Okay, so to some of you, this equation might register in your head, because this is something very what's the word? Similar. Yes, this is very similar to another equation called fs cos theta. This is more or less the same. Alright, so this is working in the x-axis. Now working in the y-axis, which is the height. Questions will come that what will be the height at this point of the time, or what will be the maximum height. I will work with time, instantaneous time and maximum height in a separate video, but now I'm going to show you the general rule. So for height, it's a bit tricky, because in the y direction we do have an acceleration. See over here, a of y is minus g. We do have an acceleration. So I'll just write y here. And since we have an acceleration, we have to use this formula, s equals u. Alright, we're back. Sorry about that. So now what happens is, like in the y direction, we'd have to substitute this for y. We're using this formula because there is acceleration. Sorry, I don't know how to spell. There is acceleration, right? So we use this formula because there's acceleration in there. So we substitute, since we're working in the y direction, we substitute everything that has y in it. So we use uy times time plus, okay, negative g, because it's ay. Okay, we're using the acceleration of y, which is negative g by 2 t squared. Okay, time again independent, doesn't matter what time, how you put time, as time will be time. Okay, so now we expand it or put it into formula, and most probably the one thing I want to mention is that the y will change to h, because we're working with height, right? We're working with height, so y will change to h. So h equals uy, which is u, I'll just do it directly, u sine theta times time, right? So ut sine theta, okay, there's u sine theta over here, and then times time, so it comes here, minus minus and plus becomes minus g by 2 t squared. That is it. These are the two formulas you must memorize, and this is how we got the formula. This video is more or less the derivation of the distances covered or the height reached in a projectile. I hope you enjoyed this video. I really hope this video helped a lot, because most of my friends have had trouble differentiating between what ux is and what x is. And I'll say this again, this x that we see is in meters. The ux is not like a part or like a magnitudinal part of this graph. The length of u can go on and on or be shorter and shorter, but it will be the same. The u will be the same. It doesn't really matter. Okay? And if you say that these will shrink and get big, well, they shrink and get big in ratio because they are directly proportional to this. So they will all still the same, still stay the same, u and uy and ux. They are not in length. Okay? They have a magnitude with a direction, but not in length. All right? Thank you for this video. Really hope it helped. Bye.